In this quick guide tutorial, I'll show the full process of going from a 3D scan to a finished render in Blender, using the 3D Render add-on by KIRI Engine. To find out how to use more features of the add-on, such as painting or exporting, check out the editing and mesh to 3D quick guides, as well as the full documentation videos. Okay, to get started, we need a 3D scan. I'm using this amazing scan of a wooden sculpture that was scanned by a KIRI Engine user and was shared on the KIRI Engine app homepage, where you can find a bunch of free scans. In the exported folder for the scan, I can find the scan as a PLY file. Now in Blender, I have the add-on opened, and I'll go to 3D import PLY as splats. I'm not doing any crazy shader animation, so I'll leave UV reset unchecked, hit OK. And now I want to find my PLY file. There it is. Press import and wait. Okay, now the scan is imported, and it's quite hard to tell what's going on here. So I'm going to look in wireframe mode with Shift Z, and I can see that this is incredibly dense. If I actually go to Edit, Preferences, Interface, Status Bar, and Scene Statistics, I can now see the number of faces in the scene. And I can see that this model is made of 400,000 faces, which is a lot. So the best thing to do at first is, for this active object, I'm going to show it as a point cloud. And pressing Z, I can go to Material Preview. Okay, with this model now set as a point cloud, it's much easier to move, rotate, adjust, just to get into base position. So I can see that right now, it's actually flipped for the Blender axes. So I'm going to rotate on the x-axis. I'm going to look forward, and I can see that it's backwards, so I'm going to rotate on the z-axis. And it's a little bit offset from the world origin, so I'm going to move it so that its base of the sculpture is at the world origin. And that is much nicer to work with. I'm going to add a camera, look through my camera, move the camera back along its own view with G, Z, Z, and pull backwards, and get a kind of nice framing just so I can see what's going on. And now we have all these points outside the camera that we don't need. And if I select the object and enable camera updates, we are going to be updating all these faces that I don't care about, which is going to slow things down massively. So I'm actually going to go to Show as a Point Cloud again, go to the modifiers, and add a camera cull modifier with the plus icon. And now we're only seeing points that matter to us. Now, if I find this padlock icon in the 3D viewport, and I press it, when I look around, I'll actually be looking through my camera, and my camera will move as I look around the scene. And because we have the camera culling modifier enabled, we'll be getting rid of any points outside the camera view. So to create a quick animation, I'm going to set up my camera animation while using the camera cull modifier and while looking at my model as points. So I'll find an OK starting position. And as I scroll backwards and move my camera backwards, I can see that we've got some points floating in front of the camera. If I actually see what this looks like as faces, it looks kind of blurry, kind of hazy. And these are sometimes called floaters in the 3D community. If I go back to showing as a point cloud and I turn the lock icon off so I can exit the camera view, I can see that there's a few points sitting right in front of the camera. And there are even some points surrounding our statue here, but I'm not going to worry about them for now. These points right in front of the camera, I can get rid of with the camera call modifier. If I go to closer than and change the closer than threshold, this will remove points closer than this distance from the camera. As I bring the distance up, we can see those points disappear. Let's see what that looks like as faces again. And if we didn't remove faces closer than, we can see it's much more hazy. We can also see some haze around the object itself. However, we're currently, if I check HQ-LQ mode, we're currently using LQ mode, Dithered Alpha. This is the mode I like to use while I'm working in the viewport, but for final renders, I'll switch to HQ mode. And I can see that makes things much cleaner, as they would be expected in a regular 3DGS viewer or editor. While working, I'm going to flip back to LQ mode. And while animating my camera, I'm going to continue to show as a point cloud. I can see my timeline at the bottom of the screen here, and I'm going to select my camera. I can see in the camera's transforms that I can add a keyframe for the camera's location and rotation by hovering over a value and pressing I. And I can see that that keyframe is on the timeline here. If I move to the end of the timeline, I can use Shift and right arrow. I can now move the camera. I could manually place the camera, or again, I can use the lock icon to move the camera as I navigate the viewport. I'll move to find another angle that I like. And when I think I'm happy, I'll select the camera again, and I can again keyframe the location and rotation of the camera. If I scroll through the timeline, I can check out the camera move, and I can see that Blender is automatically interpolating between this first position and last position, and in the middle it gets kind of lost. You can spend more time setting up a good camera animation, but I'm going to do a quick hack, which is to jump to the middle between our two keyframes and then reposition and reframe the camera. And again, hovering my mouse over the location values, pressing I, hovering my mouse over the rotation values, pressing I, we have some new keyframes here. Let's again scroll through the timeline. And we can see that the sculpture stays in frame for the duration of the camera animation. I'm happy with my camera move, but you should spend some more time on it. I'm going to keep my camera locked to the view with the padlock. Now if I look around the scene, I can still look around nicely, but because the camera animation is keyframed, if at any point I change frame or press play, the camera will jump back into its keyframed position. If I look from the top and then I press play, we jump back into the animation. I'll keep the camera locked to the current view just to make it easier to look around our scene and to cull the points outside of the camera bounds. Now I want to see how this looks with faces as a regular 3DGS scene. Back in the add-on, I'm going to go to the active object with the object selected and change from show as a point cloud to enable camera updates. Now everything is turned into faces, but it's not looking good. That's because we need all of these faces to be rotated and scaled relative to the camera's current view. So we could do this by using the scene controls or by manually clicking update all to view, but a much better way is to use active camera. We need to have an active camera in the scene to do this. We do have an active camera. We're looking for it right now, so I'm going to click use active camera. Now, whenever the camera moves, the faces of the model will move to follow the camera movement. and I can jump through parts of my timeline to check that everything's looking okay. And remember that we are currently using the LQ lower quality divert alpha for this material. Let's check out the HQ mode. And if you notice, there's a warning about using samples with LQ and HQ mode. HQ mode, you can often use one sample. Our viewport samples right now are at 16 and render is at 64, which is the default for Blender. Let's try changing both of these to 1. And there's no degradation in quality because we're not using shadows or reacting to light. This is a shadeless material right now, as you can see in the color tab. So if viewport and render samples at 1, let's try skipping through the timeline. Everything is looking good. I want to render a single frame to get a preview of whether or not it's time to render my full animation. I can do that from the standard Blender render panel or using F12, or I can render offline from the render menu in the add-on. I can see that my current view transform isn't set to standard, which is expected by 3D scans. Let's try standard, and I can see that the colors are more representative of the raw scan itself. For a little bit of style, I might adjust the look to be a bit more contrasty. And I can see that my render samples are 1. I'm going to try rendering a PNG because we need an image format for the offline render. And I'm going to check my output settings. Currently, I'm rendering to my temp directory, which is fine for this test. And I'm going to Alt-Shift-click this folder to open the folder. Here's some previous renders. And I'm going to press Render Image. A warning will pop up telling me that all objects will be now using the active camera, which this is already set to. If I want to cancel rendering at any time, I need to force close Blender since rendering is done offline. And I hit OK. And looking in the folder directory, I can see that that was very fast. And let's check this image. And it looks great. Okay, now let's see what would happen if I wanted to render an animation. My timeline is currently set to 250 frames, and that's not good for previewing, so I'm just going to change this quickly to 5 frames and press Render Animation and hit OK, and then keep an eye on my output folder. And I can see that very quickly the folder is populating with my new frames. And since I'm using my temp folder, my old renders actually were overwritten. Now let's check each of these pictures to make sure that everything's rendering nicely. They all look good. Right now I can see that the camera bounds are actually extended outside my viewport too much. And if my camera is locked with the padlock and I try to shrink my camera bounds, I'm just moving the camera. If you want to reframe your camera bounds, unlock the camera, scroll back, so you're changing the actual viewport position, not the camera, and then relock the camera, so you are now navigating through the camera view. Since I'm happy with my preview renders, I've changed my timeline back to 250 frames. I'm going to keep my temp directory, but you might want to choose somewhere safer. I'm going to press Render Animation, press OK, and the Blender viewport will freeze, and I will see the folder being populated by my renders. As soon as this is done, the Blender viewport will become responsive again, and you can use your renders as you wish. Now that the render is done, I can bring it into Blender's video editor to check it out in motion. If I click a plus icon at the top of Blender, find Video Editing and Video Editing. I can now drag and drop my image sequence onto this timeline here. The render looks quite nice, but I can see that there's some popping on the borders where splats are disappearing or entering the frame. If you keep an eye On the side borders here, we can see it clearly right here. This is due to the effects of the camera cull modifier, removing splats as soon as they exit the frame. You can try and fix this by selecting your object, going to the modifiers tab, going to the camera cull modifier and playing with the padding value. This is currently set to 0, and if I watch the bounds of my frame, let's set this to 0.1. I can see that we've got some more room here, and that popping that we noticed, those suddenly disappearing or appearing splats, should be happening outside the camera bounds. Let's watch this area right here where we saw it before. And we can see that inside the camera view looks much better, and outside we see that appearing or disappearing. For each scene you can play with different values. Sometimes a value of 0 is okay, sometimes you need to go higher. Just to be safe, I'm going to up this to 0.2. And just a word of warning, before re-rendering, make sure to clear your video editor, or when you render, you may actually be rendering the output from the video editor, not your 3D viewport. So I'm going to delete this and re-render my animation. Okay, my new render is done, so I'm going to drag this new image sequence onto the video editor, and I'm going to hide my object in the viewport to make the video editor speed up a bit and play things back, and I can see that the borders are looking much better. That is the basic quick version of this tutorial. If you want to get even better results and you want to clean up some of the fogginess and smokiness you can see around our main focus, you can see some right here, you can actually try and edit some of these floaters. And to make viewport performance even better, I can just delete points that I never want to use without relying on the camera cull modifier. I can do that by quickly going to modifiers, disabling camera cull, and now I can see all the points again. Now if I have my object selected and I go to edit mode, I may have to wait since this is such a big scan. I'm going to go to wireframe mode with Shift Z, and I'm going to select everything within my camera bounds. I'm in vertices mode, so any vertice within the camera bounds I'll be selecting, and I'll actually select a little bit outside the camera bounds. Then I'm going to move my timeline to another position, hold Shift so I keep my current selection, and select the camera bounds again. And now I'm going to scroll through the viewport, through the timeline animation, and find any moments that I don't have what is in the camera view selected. I can see now here, I'm starting to see some things that are not selected. So I'm going to select these within the camera bounds, move a little bit more, again, select the camera bounds. And now one quick check, scrub through my timeline to make sure that everything we're seeing within the camera is selected. And now if I check, we can see that anything that is unselected is never used by my animation. And that is a huge amount of points. I currently have single vertices selected, and in some cases I may have selected only one vertice of a face, and I want to make sure I'm making full face selections. So I can do that by pressing Ctrl and plus on my numpad, so that we are selecting full faces. If I press Ctrl I have inverted my selection, and I can press X to delete these faces. Let's have a look at our animation again, see if anything has been removed that we don't want. I'm going to exit edit mode, go into object mode. And I can already see that scrubbing through the timeline is much faster. And I can't see any glaring errors where I've removed too many faces. Now we can also spend a little bit of time trying to remove some of the floaters around our main subject. If I go back to edit mode, I'll go to top view, I'll go to wireframe with Shift Z and press C to go into circle select and use my scroll wheel to change the size of my selection. And I'm going to select most of the points within the center of the object. Then I'll press Ctrl I to invert that selection, press H to hide all the background points. And I can see now in rendered mode, I can turn off overlays with this button or with Shift Alt Z, and I can see that all of these faces here are floaters, which are very common on interior scans. I'll turn my overlays back on, and I can start to select these points either in wireframe mode, or if I'm lucky, in rendered view. And I don't need to select the full face, I just want at least a vertex of each face selected. And I can clearly tell by the dense outline of my main subject which of these points are floaters. A very fast way to do this is to press C key again, change the size of my select with the scroll wheel, and just paint my selection. At any point, I can make sure that these vertices selections turn into full faces, like this face here, by pressing Ctrl+. I have full faces selected, pressing X to delete those faces. And that's already much cleaner. I'll keep going a little bit, making sure that this outline looks very neat and tidy. As you can see now, the center of the scan and the points surrounding the main focus are much cleaner. And I can see that from almost all angles. But we disabled the camera cull modifier and removed a lot of points manually, which is great for performance. But now we still have points outside our camera bounds that sometimes are useful for the animation, sometimes are not seen, so I'm going to re-enable the camera cull modifier. This was a super condensed workflow for creating a render, but it's perfect if you want to do something quick and get results like this. You can always spend more time cleaning up floaters and abstract points. You can also use the point cloud workflow to edit points and then move into editing faces with the 3D.js workflow. I'll show that in the editing quick guide. If you want to make your own scans, check out the KIRI Engine app, or you can check out the homepage on the KIRI Engine app to grab some free scans like this one.